Good morning everybody. Previous class we already studied real numbers. Collection of all the numbers are called real numbers and it is represented by the symbol capital letter R. Today we will discuss about real numbers and their decimal expansions. Real numbers and their decimal expansions. Okay. You know real numbers is the collection of rational numbers and irrational numbers. Rational numbers and irrational. Today we will discuss about the decimal expansion of rational numbers. Real numbers and the decimal expansion means we have to study the decimal expansion of a rational number and irrational number. Today we will discuss only about the decimal expansion of a rational number. Okay? Decimal expansion. First we discuss about a rational number. We have to say example of one rational number, that is 7 by 8. 7 by 8. This we can represent the decimal form. Okay, that is 7 divided by 8, 0, 7 by 8. Then 8 8s are 64. Then 6. We have to put a 1 0. Then 7 8s are 56. Then 4 0. 8 5s are 40. The remainder is 0. That is decimal expansion of 7 by 8 is equal to 0.875. That is 7 by 8 is a rational number. Its decimal expansion we get 0.875. Here decimal after 3 digits, the remainder becomes 0. That's the decimal expansion of 0.7. 7 by 8 is equal to 0.875. Then we have to take another one example. Here 10 by 3 is a rational number divided by 10 divided by 3. 3 3s are 9. 1. We have to put one decimal. 10 again. 3 3s are 9. Again we have to put 1 0. 3 3s are 9. Again. Here the decimal expansion is never the remainder in this division, the remainder never becomes 0. All the things the remainder become 1 1 1 1 etc. That is the quotient decimal after one digit is repeating. That is the remainder is not equal to 0. That is the decimal expansion of 10 by 3 we get 3.3333 etc. That's the decimal expansion of 10 by 3. Here 7 by 8 is a rational number. Its decimal expansion we get is 0.875. Here the decimal after 3 digits the remainder becomes 0. Here the decimal expansion of 10 by 3 is equal to 3.33333 etc. Here the remainder never becomes 0 and the decimal after one digit is repeating. Okay. Then we have to take one more example, that is one more example of the decimal expansion of a rational number. Here we are taking as 14 by 11. Here I am writing 14 by 11 divided by 14 divided by 11. 1 time 11 we get 3. Then we have to put a 0. 11 2s are 22. We get 8. Again put on 0. 11 sevens are 77. Again 3 0. 2 we get a 22. Again 8 0 we get a 7. That is 77. Again we get a 3. That is here the decimal after 2 digits is repeating. That is 1.272727, etc. But 3 types of rational numbers I am brought here. First one is 7 by 8. Its decimal expansion we get is 0.875. In this division, numerator divided by denominator, what will happen here? Here, the decimal after 3 digits remainder becomes 0. Division finish stop. Second is, here, the decimal after 1 digit is repeated and the remainder never becomes 0. Okay, this is the second case. Then third one is another rational number. Here, the decimal after 2 digits are repeating and also the remainder never becomes 0. Okay, these are the 3 decimal expansions of 3 rational numbers. Here, we are taking 2 cases. Here I am writing one rational number here. Second one is 10 by 3. We get a 3.333, etc. Then 14 by 11. We get a 1.2727, etc. Okay, this is the first case. In this case, the numerator divided by denominator, that is in the division, the remainder becomes 0 after some steps. Here after 3 digits, after 3 steps, the remainder becomes 0. This type of decimal expansion is called a terminating decimal expansion. That is, the remainder becomes 0. This type of decimal expansion is called a terminating decimal expansion. But this is a rational number. It's the one type of decimal expansion is terminating decimal expansion. In this case, numerator divided by denominator, that is in the division, the remainder becomes 0 after some steps. Okay? Then, next case, 10 by 3. Second case. It is also a rational number. These are 2 are second case. Here, numerator divided by denominator. In this division, the remainder is never, the division is continuing. Here after 3 digits the division stop. That is terminating decimal expansion. I am writing here. Terminating decimal expansion. Okay. Second case, 3.33333, etc. The division is continuing and the remainder never becomes 0. The division never ends. This type of decimal expansion is called non-terminating. Remains 0 non-terminating and also recurring. 1 digit or here 2 digits or a block of digits is repeating. That type of decimal expansion is called non-terminating recurring. Or one more name is non-terminating repeating decimal expansion. Okay, second case listen. 10 by 3. Here we get 3.3333, etc. This division usually end cheyilla and 1 digit is repeated. This also we can pass 3.31. That is a bar above the digit is repeated. That is the meaning of the bar. 3.3 bar means 3.3333, etc. That etc. represents the bar. And then we have to put the bar above the number. That means this only that 3 number is repeating. This decimal expansion is called non-terminating recurring. This one also same. Division never ends and the quotient a block of digits is repeating. Here 2 digits are repeating. 27, 27, 27. Here only 1 digit is repeating. Both decimal expansions are called non-terminating recurring or non-terminating repeating decimal expansions. Okay. Here we are writing 1.272727 bar. We can written as 1.27 bar. It's a bar above the digits are repeating. 27272727, that is repeating. Okay, we have to put a bar. The digits, we have to put a bar. The bar representing the digit is repeating. Non-terminating recurring decimal means it never ends. The division never ends and the remainder never becomes 0, and in the quotient one digit or a block of digit is repeating. That type of decimal expansion is called non-terminating recurring or non-terminating repeating. That is, real numbers have two types of decimal expansion: terminating and non-terminating recurring. Terminating means in the division after some steps the remainder becomes 0. Non-terminating recurring means the remainder never becomes 0, means the division never ends, and in the quotient one digit or a block of digit is repeating. Understood? Listen. Rational numbers have two types of decimal expansions: terminating decimal expansion. This one is non-terminating recurring or repeating decimal expansion. That is, rational numbers are two types of decimal expansion. That is, this one is one way, terminating decimal expansion. Here, non-terminating recurring or repeating decimal expansion. Terminating decimal expansion, easy we can write that type of expansion. That is 0.12. Decimal after only two digits are there. That is the division ends and remainder becomes 0. Or we can write 0.4134. Okay, or 0.05 or 0.2. All are examples of terminating decimal. What are the examples of non-terminating recurring decimal? That we can ask 0.222 etc. 1.333 etc. 0.2121 etc. These are the examples of non-terminating recurring decimal. Here we have to put the bar. That is 0.222 etc. means 0.2 bar. The repeating digits, the bar representing the digits is repeating. Here only 1.3 is repeated, only 3 bar. Here 0.2 digits are repeated, that is 21 bar. These are the examples of non-terminating recurring or non-terminating repeating decimal expansion. Here this is terminating decimal expansion. That is, rational numbers have two types of decimal expansions: terminating and non-terminating recurring. One more name is non-terminating repeating, or it is two types of decimal expansions. Where rational numbers have two types of decimal expansions. First one is terminating. That means in the division after some steps the remainder becomes 0. Okay. That type of decimal expansion is called terminating decimal expansion. In the second case, in the division, the remainder never becomes 0, and in the quotient, one digit or a block of digits is repeating. That type of decimal expansion is called non-terminating recurring decimal expansions. Okay. Next class we will discuss about the decimal expansion of an irrational number. Okay. So, rational numbers have two types of decimal expansions: terminating decimal expansions and non-terminating recurring decimal expansions. Okay, thank you all.